So I just talked about graphing piecewise functions, and now I'm going to talk about evaluating piecewise functions. And it's not too bad trying to evaluate a piecewise function if you're looking at a graph. So I'm just going to talk about if you're not looking at a graph, how do you go about evaluating it? Alright, so first thing we're going to look at is f of negative 4. So basically you need to ask yourself, where is this on my domain restrictions of my piecewise function? Okay, so f of negative 4, is that on this part of the domain where x values are less than negative 2? Is it on this part of the domain from negative 2 to 2, or is it an x value greater than 2? So hopefully you said to yourself, that's on this part of the domain. Negative 4 is an example of a number that is less than negative 2. Okay, so that means that we're plugging into this function. So we plug in negative 4 in for this x value. So we do 1/2 of negative 4, which is negative 2, and we add 4 to it, and we get 2. Alright, let's look at the next one. F of 2. Alright, so you need to ask yourself, where is 2 on these domain restrictions? Okay, so I'm noticing that I have 2 right here and right here. Basically, I want the part of the domain that includes the 2. So notice this has less than or equal to 2. This has greater than 2. Okay? So we choose this part of the domain to represent f of 2, which means we're plugging into this function. We're plugging x equals 2 into this function. So 2 squared is 4, minus 1 is 3. Alright, last one. F of 3. We want to find where is 3 on these domain restrictions. Okay, so 3 is an example of a number that is greater than 2. So I plug in here, and there's nowhere to plug in, so it's just negative 1. Remember, that's a constant function, so there's nowhere to plug in an x. It's always negative 1. It's constantly negative 1. So let's do another example. Here we've got a piecewise function with an absolute value function that's translated 2 units to the left. We've got a square root function, and we've got a linear function. Okay, and the absolute value function is defined from negative 6 to 0. And notice both of these inequality signs are or equal to. So in terms of graphing, those would be closed endpoints. The square root function is between 0 and 1. Notice that this 0 does not have an or equal to. And that makes sense since this one did. If they both had an or equal to, we wouldn't have a function on our hands. So at 0, at these cutoff points, only one of the functions can have the or equal to. So this goes from 0 to 1. It doesn't include 0, that'll be an open point, but it does include 1. And then our last function, our linear function, goes from 1 to 5. And notice neither of these has an or equal to, meaning both of those endpoints will be open points. Alright, so let's practice evaluating these. So our first thing that we need to evaluate is f of negative 3. Okay, so you need to ask yourself, out of all of these domain pieces, where does negative 3 fall? So hopefully you're thinking it falls between negative 6 and 0, which means we're going to be plugging in here. Alright, so we'll do negative 3 plus, whoops, don't want to close my absolute value yet. Okay, so negative 3 plus 2, close absolute value. Okay, so negative 3 plus 2 is negative 1, and the absolute value of negative 1 is 1. Alright, let's try another one. F of 0. So you need to be asking yourself, where on these domain pieces does 0 fall? And notice, 0 is one of the cutoffs that I pointed out. We've got 0 here, and we've got 0 here. Which one do I want to use? I want to use the or equal to, right? So I want to use this function. I'm going to be using the absolute value again. So I'm going to do absolute value of 0 plus 2. That's just the absolute value of 2, which is just 2. Alright, and then f of 3. Ask yourself, where does 3 fall on these domain pieces? Hopefully you're thinking between 1 and 5, so we'll plug into this function. Alright, so negative 2 times 3 would be negative 6, plus 5 is negative 1. Okay? And then lastly, I'm doing another example that falls on a switching point where we switch between functions. So f of 1, notice we've got 1 here and we've got 1 here. Which one should I choose? I should choose the one that has the or equal to. So I'll plug into the square root of x, so the square root of 1 is just 1. Alright, so there's how we evaluate piecewise functions without having the graphs to look at. You really just need to choose between the pieces of the domain and say, which domain do these numbers fall under? And then just plug into the function associated with that part of the domain.